So in this video, we're going to be discussing how do we describe the domain and range of real-world functions. So mainly what we're going to be looking at is word problems. So in this first word problem here, we have that Hector's Service Club is raising money by wrapping presents in the mall. The function f of x equals 3x describes the amount of money in dollars the club will earn for wrapping x presents. They only have enough wrapping paper to wrap 10 presents. Describe the domain and range for the word problem. So the first thing I think you guys need to highlight is basically separate your information between the input, which is the domain, and the output. So the best way to figure out where your input is just by looking at the function. We're saying you have the function f of x equals 3x. So your input is x. Notice I am not going to highlight f of x because remember f of x means your output. So x here means my input. And then I'm going to keep reading and see if they told me what x means. They will always definitely label the variable when they're talking about x. So right here it says the club will earn for wrapping x presents. So I can tell that x means presents. Okay, now that I know that x means presents, I want to see if I have any more information about the amount of presents here, which represents x. So this sentence right here says that they only have enough wrapping paper to wrap 10 presents. So I would definitely highlight that as well in the same color. Okay, so we definitely have enough information now to kind of talk about our domain already. And I always like to sort of like organize this stuff in a table before I answer the question. So my input here is x, which is presents. I'm just going to put x. And they are telling me that I only have enough wrapping paper to wrap 10 presents. Now, the least amount of wrapping paper that you, the least amount of presents that you can wrap is 0 because you can decide not to wrap anything at all. So we're going to put 0. Now the next amount that you can wrap is 1 because you can't wrap a half a present, and then 2, 3, 4, 5, 6, 7, 8, 9, and 10. So this right here represents my domain. My domain here is obviously discrete because it's not all the numbers, even including the decimals. So right here, when I am answering this question, I'm going to say that this is a discrete situation. And I'm going to have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 as my domain. Now, my range is something that we're going to have to do some work for using what we know about function notation. Your range here is, let's use here this, it's f of x. And they're telling me this information here about what I'm doing to x to get f of x. Well, I'm multiplying it by 3. So basically, every present is worth $3. So f of x, which means, let's go back here to see what it means. It is usually describing what the function is about. So they're saying that the function f of x equals 3x describes the amount of money in dollars. So remember, your output or your f of x is always the function value. So I have amount of money, and this is my f of x. And we're going to find how much money each present costs by, again, multiplying by 3 here. So if I wrap 0 presents, I'm going to make $0. If I wrapped 1 present, I'm going to get $3. And then $6 for 2, $9 for 3, $12 for 4. So for 5, we're going to have 15, 18, 21, 24, 27, and then 30. So the maximum money we can make is 30. So here, let's go ahead and label our range. So because we're only inputting specific amounts of presents, we're going to get specific amount of money. So my range here is going to start with $0, then $3, then $6, $9, $12, $15, $18, $21, $24, $27, and then lastly $30. So again, we have a discrete situation where our input is specific numbers and our output is specific numbers. Okay, now this next situation here, we're going to go ahead and do the same thing. We're going to read it, and then we're going to highlight our input and highlight our output and determine what type of situation it is. So Sally's family is taking a road trip to Houston. Her family is trying to budget the amount of money they need to get to have for gas there. Depending on the route they take there, they will travel 239 miles to 275 miles. The cost of gas is a function of the number of miles they drive and can be represented by the equation G of M equals 0.30 m, where m is the number of miles they drive. So again, we're trying to figure out what our input variable here is. So our input variable is obviously m, and they're telling me that m means the number of miles. So we're going to look here if we have any information about how many miles they can drive. Well, right here on the top, they say they can drive between 239 miles to 275. So great, I have my domain. So when I'm thinking about miles, you can definitely travel between. So it's all the numbers between, even like 239.5, 239.2. So this is a continuous situation. I am not going to be able to list out all of the numbers here, but we can go ahead and get an idea. So my input here, which is miles, well, the least I can travel is 239. The most I can travel is 275. So now, let's talk about how we would represent this as my domain. So we talked about that when we're trying to get an interval, we're going to do inequality notation. First we put 239 is less than, and we're not using x here, we're using m for miles, is less than 275. And because it says between, it's just going to be between those numbers. We're not going to go ahead and put those equal signs. Now with a different highlighter, we're going to highlight what my range is. So my output here is G of M. And again, G of M represents the function. So right here they said that the cost of gas is a function. So this is the function. This is what G of M represents. It represents the cost of gas. And obviously right here inside my equation, I have what is the cost of gas? Well, it's 30 cents per mile. Okay, so we're going to go ahead and put our cost here. And what we're going to have to do is we need to calculate what the smallest cost is if you travel 239 miles and the biggest cost. So first we're going to go ahead and do 239 times 0.30. And so we're going to go ahead and put 0 as a placeholder here, and 3 times 9 is going to be 27. 3 times 3 is 9, plus 2 is 11. Carry up the 1. And then 2 times 3 is 6, plus 1 is 7. And then we're going to go ahead and put our decimal point here 2 over, because there's a decimal point here 2 over. So that means that the least that we're spending on gas is $71.70 for this road trip. And then we're going to go ahead and do the same thing here with 275 times 0.30. So again, go ahead and put that 0 as that placeholder. And here we have 15. Here we have, so 7 times 3, which is 21, plus 1 is 22. 2 times 3 is 6, plus 2 is 8. And so the most is 82.5 or 50 cents. So again, we're going to, because this is a continuous situation, we're going to use inequalities to go ahead and represent this. So the smallest amount that I'm going to have is 71.70. And the least amount that I have for G of M the most amount that I have, is 82.50. And there we go. So this is my range for the situation, which represents the amount of money that we can spend. All right. Now let's talk about this next example, which is a little bit more interesting. So here we have the number of trolley trips TFP needed to transport P people in one day at Magic Kingdom can be found using the function TFP equals P over 100. So let's kind of think about this. This basically means that 100 people fit inside the trolley. So if there are no more than 52,000 people that visit daily, what is the domain and the range of the situation? So first of all, let's go ahead and identify our input here. Our input here is P, and they're telling me here that P means people. And so they're telling me that I can have no more than 52,000 people. Well, let's think about people. Well, you can either have 1 people, 2 people, 3 people. So this is a discrete situation. Yes, it's a lot of people. 52,000 is a lot, but it's not all of the real numbers between 0 and 52,000. So again, here I think we can go ahead and skip in the table because we can understand what's happening. So the least amount of people that I can have is 0, right? And then I can have 1, then I can have 2. So I'm not doing an inequality here because it's not all the numbers. And obviously we can have 3, but we're not going to go ahead and write all the numbers from here to 52,000 because it's a lot. So we're just going to write 52,000. And then now with a different highlighter, let's highlight our output or our range here, which is TFP, and TFP represents here the number of trolley trips. They told us that on the front in the beginning. And so, well, the number of trolley trips depends on the number of people, right? Obviously, if you have 0 people, there's going to be 0 trolley trips. Now, if you have one person, still it's going to be 1 trolley trip. 2 people, still going to be 1 trolley trips. The time that it's going to become 2 trolley trips is when you have 101. When you have 201, then it's going to become 3 trolley trips, right? And then this is going to keep going until your maximum amount of trolley trips. Well, I can take 52,000 and divide it by 100 because 100 people are the ones that fit in the trolley. And of course, these zeros cancel each other out. And so you're left with 5,200 trolley trips being the maximum amount. So my range here is, again, it's discrete. So it's all the numbers from 0 to 520. And we're not doing an inequality because it's not all the real numbers. It's just the integers. And now let's look at our last example. So in this example, we're talking about that the cost of hiring a painter is a function of the number of gallons of paint used. So again, my function is the cost of hiring a painter. So that's obviously my range, and it's a function of, so the thing that I'm inputting is the number of gallons of paint used. So you can only use whole gallons of paint in this situation. And the painting company charges $75 per gallon up to a maximum of 9 gallons plus a $60 hiring fee. This can be represented using the function. So let's talk about the input first. So our input here is obviously G. So this is what the function is about. So it's of the numbers of gallons of paint used. So I'm plugging in the numbers of gallons of paint used, and obviously I'm getting out the cost. Let's see if we have any other information about gallons of paint used. So if we read this, it says that you can have an up to a maximum of 9 gallons. Okay, so my input is gallons. My output is cost. They also told me here about the gallons, you can only use whole gallons of paint. So all of the stuff that's talking to me about the gallons is talking to me about the domain. Because I can only use whole gallons of paint, this situation is discrete. So we're going to use a set to talk about it. So the least that I can have is 0, then 1, then 2, 3, 4, 5, 6, 7, 8, 9, and that's about it. It's a maximum of 9. Okay, so that is my domain, just because I can only use whole gallons of paint. Now my range is my output of the situation, which is C of G, which is the function value, which is, I talked about here, the total cost of hiring a painter is a function. All right, so they're telling me that basically they're saying the same thing up here as they're saying in the equation. It's $75 per gallon plus a $60 hiring fee. Okay, so basically what we would need to do is we would need to plug in first. Okay, so if I didn't paint at all, then that would mean that I'm not paying $75 per gallon, but the $60 hiring fee for coming out. Now, if you did go ahead and try to paint a room, then it's going to be $75 plus the $60, so that's $135. If you use 2 gallons, then that's another $75, so it's $210. And then for 3 gallons, that's another $75, so it's $285. And then another $75 if it's 4, so $360. And if you guys kind of notice a pattern going on here, the 60 starting to repeat. And then it's going to be another $75, so $435 for 5 gallons. So right now we have 0, 1, 2, 3, 4, and 5. So if we had 6 gallons, that'd be another $75, which is $510. If it's 7 gallons, then we would have another $75, which is $585. And then if we had 8 gallons, it'd be another $75, which is $660. And then the maximum cost here would be for 9 gallons, so that would be $735. So that is the domain and the range in the situation. And this specific question is asking what's the greatest value. So my greatest value of the range would be $735. That's the most that I can spend for hiring a painter. Okay, so that is the end of this video, and I hope that you found this helpful.